Assalamualaikum and hello to our beloved lecturer and fellow friends. Today we're going to present about the solution for group assignment 2 that we made. Before that, let me introduce our group mate, which consists of 5 group members: Nur Umairah, Amirah Sofia, Afi Ikmal, Helmi Putra and Amir Daniel. So let's get started. For question 1A, what is each DMU in this real-world case study? The answer is Road Traffic Safety Evaluation. Okay, next. For question 1B, define at least 4 input variables as the choice of input are based on a set of ways that make roads safer. Okay, for this question, Afiq will explain more about the input variables. Next, for question 1C, Helmi will explain more about that. And Ame will explain further about the question 1D.
The 4 input variables are: the first one is safety, where the traffic police help improve road safety and traffic flow by enforcing driving regulations. They also regulate traffic at the scene of an accident and investigate accidents. Traffic enforcement has been aided by the use of technology such as radar, video camera and inductor loops. Second one is maintenance, where the life of road structure depends on the quality of the maintenance and minor renovation. Maintenance keeps the roadway safe, provides good driving conditions and prolongs the life of the pavement, thus protecting the road investment. Third is speed. Speed enforces both the risk of crash and the consequences. There are a variety of ways to reduce the vehicle speeds, including legislation, road design, and stricter enforcement, such as speed camera. A system in which the vehicle knows the speed limit for the route it is driving on and activates visual and audio signals if speed are exceeded. Last one is visibility. Many crashes result from road users failing to see each other. Poor visibility is a serious problem in our countries, where roads are often badly lit at night and motorized traffic is not separated from cyclists and pedestrians.
In this section, we will discuss about what is an undesirable output variable in DEA model. Can we use the same classical DEA model to obtain efficiency value when there is undesirable output? Undesirable output, or we can call it as the bad output, is related to efficiency measurement. Efficiency measurement in DEA usually they based on the assumption that input have to be minimized and output have to be maximized. As we know that efficiency exists when our DMU is equal or less than 0. If our DMU is not fulfill that efficient condition, then there are some undesirable output variable in our DM model, so that we cannot use exactly the same classical model to obtain efficient value when there is undesirable output. So at least we need to try to modify our DM model to this situation, and undesirable output should not maximize at all. The increase undesirable output will reduce the efficiency of the MU. Therefore, undesirable output increase, then efficiency of the MU will decrease.
It is undesirable outputs. According to above statement, undesirable outputs of production and social activities, number of fatal accidents and the number of minor accidents, both are being increasingly recognized as dangerous and undesirable. An output is considered as undesirable in the production process if more of it being produced from the same amount of output is not wanted. Road traffic injuries are a major but neglected global public health problem requiring concerted effort for effective and sustainable prevention. Of all the system that people have to deal with on a daily basis, road transport is the most complex and the most dangerous, and that's why they are being classified as undesirable outputs.
Next, Amira Sofia will explain more about question 2.
So for the question 2, question 2 will discuss all about AHP, analytical hierarchy process. So for the question A, 2A, they ask us about to define at least two more criteria, and in my case, I define three criterias. Three criteria, which are, the first one is payment flexibility. Well, payment flexibility has become one of the most important factors to the companies to get from the supplier, because they'll probably choose any payment method, any supplier that offers payment flexibility, which are considered to be easier for them to do a transaction process. And then for the second one is the variousness. Companies would probably like any supplier that have a variety of choices, so they can choose any product that suits their budget, that suits their preferences. And then for the third one is location. Well, the strategic location of the warehouse is also important. If the company wanted to pick up the item by themselves, for example, in a hurry situation. And then moving on to the question B. Question B, they ask us to consider the above criteria, which are cost, quality, and timeliness, and then introduce three different suppliers that we know. And in this case, we are introducing Nestle, Mondelez, and Kellogg's. And then they ask us to further rank these three alternative suppliers. So the first thing is to rank the supplier. We need to have our AHP table. So if you notice, in the main diagonal of the table is always B1. Well, this is because if in the main diagonal must be the particular supplier versus the same supplier. Let's say it is Nestle versus Nestle, so it must be 1. And then Mondelez versus Mondelez is another one, and then Kellogg's versus Kellogg's is 1. So but however, if Nestle versus Mondelez or Kellogg's, it would not be 1. It can be 1, but it can be another values as well. For example, in this solution, Nestle versus Mondelez is 2, and that makes Mondelez versus Nestle is 1/2. It should be the other way around lah. So for the first step is to sum up the values in each column of the pairwise comparison. So you should total up the values by the columns. And then for the second step is to divide each value in a column by its corresponding column sum. So for example, Nestle is 1, and Nestle versus Nestle is 1, and then the column total for that column is 17/10. So you have to divide 1 by 17/10, which makes 10/17. And then next step, which is the third step, is to average the values in each row. So for the row, you must add everything and then divide by 3, because we have 3 n values. So and then you'll get the row average. And then once you get the row average, you will be able to do the criteria table. So the criteria table should be for the table cost, and then you should key in the value Nestle, and then the cost from the row average from the cost table, and then the row average from quality table, and the row average from timeliness table. So from here we can say that for the cost, the best supplier is Nestle, followed by Mondelez and Kellogg's. And for the quality, the best one is Mondelez, and then the second best is Nestle, and the very least best is Kellogg's. And for the timeliness, the very best one is Nestle, followed by Kellogg's and Mondelez. So So that is for the supplier. So now we rank the criteria. Basically, the steps are all the same. It's very just the same as the first one, as the supplier one. So you'll get the overall. You get the and then next thing is you get the overall ranking. In this overall ranking, it comes from the previous one that we get from the supplier ranking, and then the preference vector, it comes from the row average in the third step for ranking the criteria. So now to calculate the overall score, we must times the cost in, for each supplier. So for Nestle, we times 0.5813 from cost with the criteria in the preference vector, which is 0.3 plus 0.2395, which is from quality, times another preference vector from quality, which is 0.3896 plus Nestle timeliness 0.5397 times another preference vector from the timeliness 0.3104, and that sums 0.4352. And the same thing happens to Mondelez and Kellogg's. So now we get the overall score, which are 0.4352 for Nestle, 0.3868 for Mondelez, and 0.1799 for Kellogg's. So in this state, you can see that Nestle has the best one, so it ranked as 1, and Mondelez is the second one, and Kellogg's is the third one. So based on this AHP programming model that we have calculated, it is proven and it is shown that Nestle is the best alternative. So the company might concede to to get Nestle as their supplier. So that's all. Thank you.